Supreetha. Welcome to my math class. In our previous session, we had studied about complementary functions, right? We found the complementary functions of homogeneous differential equations. Agree. Now in this session, let us focus on non-homogeneous differential equations, right? Say for example, we have f of d into y is equal to e power ax, right? So we have x terms over here, so it is non-homogeneous. When we have this type of problem, right, so let me take this as case 1. We have 2 or 3 more types of non-homogeneous differential equations. Let's study about all of them one by one. Okay, so the first one says f of d into y is equal to e power ax. Now to solve this type of differential equation, firstly, the first step says to find the particular integral, write 1 by f of d into e power ax and then replace d with a. Okay, a would be the coefficient of x over here. Agree. And clearly f of a should not be equal to 0. Now a question arises, right? What do we do when f of a is 0? So if f of a is 0, we take this part of the equation, we differentiate the denominator. Yes, we differentiate f of d, we get f dash of d, and multiply x to the numerator, e power ax remains as it is. After multiplication and differentiation, now again replace d with a in the denominator. Again, f dash of a should not be equal to 0. Again, if it is equal to 0, again what do we do? Again, differentiate the denominator, it becomes f double dash of d. Multiply x to the numerator, x square e power ax. This is equal to, again replace d with a, we get f double dash of a e power ax. Again, f double dash of a should not be equal to 0. If it is equal to 0, again you just continue the process, right? Whenever you have a differential equation, once you keep on differentiating it, at some point you would get a constant, you can stop doing this method. Agree. Now for understanding this in a better way, let us solve a problem. Okay, say for example we have solve d square y by dx square minus 6 dy by dx plus 9y is equal to 3 e power minus 4x. So we know that the solution, general solution y is always equal to CF plus PI. How do you find the CF of the given differential equation? We can rewrite the differential equation as d square by dx square, I did as capital D square, minus d by dx would be d plus 9, I have taken the y common, this is equal to 3 e power negative 4x. Right. Now to find the CF, the first step is to find the auxiliary equation. What is auxiliary equation? Just replace d is equal to m in the given equation, in the given question over here. Right. RHS would be 0. Agree? So what happens if we replace d as m, we would be getting m square minus 6m plus 9 is equal to 0. This is our auxiliary equation. Now go back to the basic rules of finding roots. So we know that 3 into 3 is 9 and 3 plus 3 is 6. Give negative signs to each term. We would get m minus 3 the whole square is equal to 0. So the roots are 3, 3. So how do you write the CF when we have real and equal roots? when we have, say for example, m1 equals m2 equals m, our CF would become a plus bx into e power mx. Agree? We just studied about this in the previous session, right? So now let me write the CF for our given question over here. So we would get CF is equal to a plus bx into e to the power 3x. So we are done with what? We are done with CF. Now the next step is we will have to find PI. What did we just study? We just studied that for finding PI, that is a particular integral, write 1 divided by f of d. What is f of d in our given question? It is d square minus 6d plus 9, right? So let us just write it down, d square minus 6d plus 9 into what do we have on the RHS? 3 e power minus 4x, write the whole term over here in multiplication, 3 e power minus 4x. And this is the first step. After this, what should we do? Replace d with a. What is the value of a over here? A is always the coefficient of x in this power term, right? E power some value into x, right? That is the value of a. So clearly the value of a over here is negative 4. Agree? Let us replace d as negative 4 in our particular integral. We would get 1 by minus 4 the whole square minus 6 into negative 4 plus 9. This term remains as it is. You can write 3 over here. Since you've substituted, just write the term over here. Yes. So what happens to our term? We would be getting 3 e power negative 4x, 4 4 16, 6 4s are 24 plus 9, right? 30, 40, 49, right? So we would be getting 3 by 49 e power negative 4x. That's it. This is our particular integral. So finally write down y is equal to CF plus PI. What is the value of CF that we've got? We've got a plus bx into e to the power 3x plus the value of pi is 3 by 49 e power negative 4x. Yes, so this is our general solution or the final solution of the given problem. Now let us solve another question. Say for example we have solve d cube plus d square plus d plus 1 whole thing into y is equal to e power 3x plus 4. Okay. Now the same thing, to find the value of y, right? The general solution y, the first step is find the auxiliary equation, right? We would be getting m cube plus m square plus m plus 1 is equal to 0. This is our auxiliary equation. Yes, in the given question, whatever you have, replace d with m. We have m cube plus m square plus m plus 1. Okay. Next, what do? We just find the roots here. Yes. Let me just take out m square common, m plus 1 would be left, plus 1 common, we have m plus 1. Again, this is equal to 0. n plus 1 is same, so just write it in a bracket, take it out as common. The remaining term, you write it in another bracket. This is equal to 0. Now, we equate each term. M plus 1 is equal to 0. And m square plus 1 is equal to 0. M will be equal to negative 1. And m square is nothing but negative 1 again. What is square root of negative 1? Square root of negative 1 is plus or minus I, right? Complex roots. Now to find or to write the CF of the given roots, how do we write the CF? We write it as a e power negative x plus, whenever we have plus or minus I, how do you write the CF? In our previous session we just studied, right? So whenever we have the root m in the form of a plus or minus ib, then CF would be e power ax into a cos bx plus b sin bx. Agree? So here we don't have a, right? A is 0, we have only b, and e to the power 0 is 1. So I can directly write, I can change the constants, right? So cos b value is 1 over here, because 1 into I is I, right? So 1 into x is x. So I can just write it as b cos x, c sin 1 into x, which is nothing but x again. So we are done with finding the complementary function of the given differential equation. Agree. Now let us find the particular integral. How do you find the particular integral? Firstly, the given question, whatever we have, the f of d part, write it in the denominator, that is dq plus d square plus d plus 1. dq plus d square plus d plus 1 into, what do we have in the RHS part? We have e to the power 3x plus 4. Agree. What do we have in the question? dq plus d square plus d plus 1. Right, so I have written it down into, we will have to write the RHS term, that is e power 3x plus 4. Let me write it, e power 3x plus 4. Okay, so we replace d with what? We replace it with a. I always told you that a is nothing but the coefficient of x. Agree. What is the coefficient of x here? Over here, the coefficient of x is clearly 3, right? So the value of a would be 3. So let me write it down. Let me just substitute. We would get 3q plus 3 square plus 3 plus 1. Agree. What is the value of 3 cube? 3 cube is 27. Don't forget to write e power 3x plus 4. E power 3x plus 4. Okay. So yes, 3 3s are 9. 9 3s are 27. 27 plus 9 plus 3 plus 1. So we would get 30, 39 and 40. Right. So we would get e power 3x plus 4 divided by 40. So what is our general solution, or we also call it as complete solution? Okay, complete solution of the given differential equation would be y is equal to cf plus pi. What is the value of cf over here? The value of cf is nothing but complementary function, that is, we just found it, no? It was, okay, -1. Yes, a e power negative x plus b cos x plus c sin x plus, what is our pi? Pi was e power 3x plus 4, e power 3x plus 4 divided by 40. As simple as that. Okay, let us move on to our next question. Yeah, so our third question says solve d square minus 4d plus 13 whole thing into y is equal to e power 2x. Okay, now to solve this equation, as usual, the same step for all the problems. Find the auxiliary equation, replace d with m, we would get m square minus 4m plus 13 is equal to 0. Now clearly 13 is a prime number. We cannot use the splitting the middle term form. So let us use the formula, that is m is nothing but minus b plus or minus square root of b square minus 4ac by 2a. This formula is used for all the quadratic equation of the form ax square plus bx plus c is equal to 0. Clearly, on comparing, we can say that the value of a, compare, we have 1 over here, right? 1. The value of b is negative 4. Value of c would be 13. Agree. Now let us substitute these values over here. M is equal to positive 4 plus or minus square root of 16, right? 4 square is 16 minus 4 into 1 into 13, right? So let me write it as 4 into 13 divided by 2 into 1, which is nothing but 2 itself. So 4 into 13 is nothing but 52, right? So M is equal to 4 plus or minus, and how much is 52 minus 16? It is 36. We would get minus 36 by 2. This square root of minus 36, we can surely write it as minus 1 into 36. So you can split it, right? Minus 1 into minus 1 root and root 36. Because square root of negative 1 is I, we already know that. And square root of 36 is 6 divided by 2. In the numerator we have 2 common. Let us take it out. We'll get 2 into 2 plus or minus 2i, 3i, right? 2 3s are 6. Okay. 2 3s are 6 divided by 2. So 2 and 2 gets cancelled. So the value of M is nothing but 2 plus or minus 3i. So clearly, how can we write the CF as? The CF would be e power ax. So in place of a, let me just write it down. In place of a we have 2, in place of b we have 3, right? This is a and this is our b. Clearly CF for complex roots would be e to the power ax. Let me just write it down. E to the power ax into a cos bx plus b sin bx. Yes, so what happens next is write it as e to the power 2x into a cos 3x plus b sin 3x. So we are done with half of the problem, that is we have found the CF, complementary function. Now this next step is we will have to find the particular integral. How do you find the particular integral? The same steps. Write it as 1 by the question, that is d square minus 4d plus 13, and what do we have in the RHS part over here? E power 2x, right? E power 2x. Now what is the value of a? The value of a is nothing but the coefficient of x over here. So the coefficient of x is 2, right? So the value of a is 2. You just have to replace d with a, which is nothing but 2. So write it down. 1 by 2 square minus 4 into 2 plus 13 e power 2x. 4 plus 13 is 17 and minus 8 is 9, right? So 1 by 9 e power 2x. This is our particular integral. So we know that the final solution or the complete solution of all this type of problems is CF plus PI. So what was our CF? Our CF was e power 2x into C1 cos 3x plus C2. Okay, we just wrote it as A and B, right? Anything is fine. Let me just replace it. A cos 3x plus B sin 3x plus 1 by 9 e power 2x. As simple as that. Okay, let us solve another question, that is our fourth question, which says solve d square y by dx square plus 4 dy by dx plus 5y is equal to minus 3 sine hyperbolic x. So sine hyperbolic x, we should already know the formula for sine hyperbolic x, which is nothing but, let me write down the formula over here. Sine hyperbolic ax is nothing but e power ax minus e power minus ax by 2. This is a very important formula. Everybody have to know this. That is, sine hyperbolic ax is nothing but e power ax minus e power minus ax by 2. Clearly in our question we don't have a, right, which is nothing but 1. Agree. So let us just rewrite the given question. I will be writing it as d square plus 4d plus 5 whole thing into y is equal to minus 3 is a constant coefficient, right? It remains as it is, into e power x minus e power negative x by 2. Yes. So let us start with the usual steps, that is finding the auxiliary equation. We would get m square plus 4m plus 5 is equal to 0. We know that 5 ones are 5, agree, and 5 minus 1 is 4, but we cannot use that, right, because 5 minus 1 we need positive 4. Let us just use the formula, right? That is, m is equal to negative 4 plus or minus square root of b square, that is 16 minus 4 1 into 5, that is 20, divided by 2. Clearly we are getting a negative sign, right? So we have minus 4 plus or minus square root of negative 4 by 2, which is nothing but minus 4 plus or minus 2i, right? So take out 2 as common. In the numerator we would get 2 into negative 2 plus or minus I by 2, which is nothing but 2 gets cancelled. We will be left with minus 2 plus or minus I. Yes, that is the value of m minus 2 plus or minus I. Okay, so clearly if we have to write the CF of the given root that we've got, the value of a is negative 2 and the value of b is 1, right, because 1 into I is 1, 1 into I is I. So the CF would be e to the power ax into a. For a change, let me write it as sine bx plus b cos bx. These are constants, right? It doesn't matter, the order doesn't matter over here. So we have e power minus 2x into a sine x plus b cos x. So after finding the CF, as usual, let us move on to our particular integral, that is pi. The pi for the particular problem would be 1 divided by d square plus 4d plus 5 into minus 3 by 2 e power x minus e power minus x by 2. Okay, I have already written the 2 over here, right? So yes, we can just write the constant over here 3 by 2. Now since we have two terms, let us give our 1 by f of d term. 1 by f of d, this term, let us multiply it to each term over here. Okay, so we would get 1 by d square plus 4d plus 5 into e power x minus 1 by d square plus 4d plus 5 e power negative x. Agree? So in our first term, the value of a over here is 1, right? Because the coefficient of x is nothing but 1. Over here the coefficient of x is negative 1, so the value of a is negative 1. So let us replace these, right? So we will get minus 3 by 2 into 1 by 1 square plus 4 into 1 plus 5 e power x minus 1 by minus 1 the whole square plus 4 into minus 1 plus 5 e power negative x. Yes, so what happens to our terms over here? We get minus 3 by 2, 1 divided by 5 plus 4 9 plus 1 10 e power x minus 1 divided by, we have 1 minus 4 plus 5, right? So 6 minus 4 is nothing but 2 e power negative x. So what would be our pi? 3 by, you can also take 2 common, it becomes 4. We have e power x by 5 minus e power negative x. So what happens to our final solution, that is y, that is CF plus pi? Agree? So CF was e power negative 2x into a sin x, if I'm not wrong, plus b cos x, plus pi is negative, right? So negative 3 by 4 into e power x by 5 minus e power negative x, as simple as that. Yes, so moving on, let us solve another problem. So our fifth problem says solve d square plus 4d plus 4 whole thing into y is equal to e power 2x minus e power negative 2x. Okay, so the first step, as usual, find the auxiliary equation. Auxiliary equation is nothing but m square plus 4m plus 4 is equal to 0, right? We are replacing d with m and equate RHS to 0. That is what our auxiliary equation says, right? These are the steps to find the auxiliary equation. It has to be homogeneous, and we cannot equate y as 0, right? Because that is what we are trying to find. Yes, so what are the roots of the given equation? Clearly this looks like a plus 2a square plus 2ab plus b square, that is m plus 2 the whole square is equal to 0. Equate each term, m plus 2 is equal to 0 and m plus 2 is equal to 0. We get m is equal to negative 2 comma negative 2. Yes, whenever the roots are real and equal, whenever the roots are real and equal, what is the CF? The CF would be a plus bx. Since we have two roots, m1 equals m2, say for example this is equal to some m, so we have a plus bx into e power mx, right? So what happens to our solution over here? We would be getting CF would be a plus bx whole thing into e power negative 2x, right? So moving on, we are done with CF. Let us find our particular integral, that is pi. Pi is equal to 1 by what was the question? D square plus 4d plus 4 e power 2x minus e power negative 2x. This is what our question said, right? Again, since we have two terms, let us just multiply. Let us give it to each term. Okay, so we have 1 by d square plus 4d plus 4 e power 2x minus 1 by d square plus 4d plus 4 e power negative 2x. Clearly the value of a over here that we have to replace, over here it is 2, over here it is negative 2, right? So we'll have to replace d as a over here. Let us do that. So our particular integral will be 1 divided by 2 square plus 4 into 2 plus 4. This is easy, this is simple. But the next term, be very careful with the signs. Yes, so we would get negative 2 the whole square plus 4 into negative 2 plus 4. Yes, so what happens to our first term? First term, it would be 4 plus 4, 8. 8 plus 8, that is 16. Let me write this only as 2x. Right? Minus 1 divided by, we have 4 minus 8 plus 4. So what happens over here? Clearly we are getting a 0 in the denominator, right? 4 plus 4 is 8, negative 8. 8 minus 8 is 0. So this term is tending to 0. So we had seen a case, right? Whenever the denominator is 0, whenever f of a is 0, what should we do? Differentiate the denominator term. Yes, the first term remains as it is till the end. Okay, we are just doing some changes in the second term because the denominator is 0. Let's get back to our first step. Yes, this step. This step over here. Yes, what should we do? What should we do? In this step, we will be differentiating the denominator. What is differentiation of d square plus 4d plus 4? Say we have f of d as d square plus 4d plus 4. Right. So f dash of d would be differentiated. D square differentiation is 2d plus 4. Right. Differentiation of d with respect to d itself is 1. So the answer is 4. I agree. So what happens? This becomes 1 by 2d plus 4. You will have to multiply an x also. Right. Multiply x. Differentiate the denominator term. E power negative 2x. This is the rule that you'll have to follow. Okay, what are the two rules? Whenever you get a 0, when you substitute the value of a, if you get 0 in the denominator, go back to the previous step. Go back to the first step. Okay, in this first step, differentiate the denominator and multiply a x in the numerator. Yes, now let us continue. So what do we have over here? The first term remains as it is, e power 2x by 16 minus x divided by, again replace d as negative 2. Right, the value of a over here is negative 2. Again we are getting a 0 because 2 into negative 2 is negative 4. Negative 4 plus 4 is again a 0. Again the denominator is 0. So what do we do? Multiply an x again. Differentiate the denominator. We have f of d as what? We have f of d as 2d plus 4. So f dash of d is, differentiation of 2d will be 2. Differentiation of a constant is 0. Right. So we have x divided by 2. Right. We have 2. Here you've differentiated the denominator. Now multiply a x to the numerator. So we are done with the particular integral because we don't have d in the denominator. Right. So we don't have to substitute anything now. Yes, let us just revise the particular integral part. So what happened over here? We just took the question, that is 1 by, we wrote it in the form 1 by f of d into the RHS part, that is e power ax. Agree? After doing that, we just multiplied this to each term. In the first term, it was very simple. We had directly the value of a. We just substituted and we got our answer. But in the second term, what happened? While we were substituting, we saw that the denominator term was 0. Agree? Since the denominator term was 0, we differentiated. We went back to the previous step and differentiated the denominator term. We wrote it. Right? Denominator you have differentiated. And multiply an x to the numerator. After doing that, again substitute the value of a, that is negative 2 in all the steps. Okay, again when you substituted, you observe that the denominator is 0. So again differentiate 2d plus 4 with respect to d itself. Okay, you are differentiating this with respect to d. Again multiply an x to it. you get x square by 2 e power into e power negative 2x. If we had a d over here, again we would have substituted negative 2, right? But we don't have a d. So we'll just end the process over here. So what is the value of y? The value of y would be cf plus pi. I agree. What was our complementary function? Our complementary function over here is a plus bx into e power negative 2x. Right, a plus bx into e power negative 2x. What is our pi? Pi is nothing but e power 2x by 16 minus x square by 2 e power negative 2x. Okay, now let us solve another problem. Say for example we have the sixth problem. Yes, sixth problem says solve d square 4d square minus 4d plus 1 is whole thing into y is equal to 4. What would be our auxiliary equation? Our auxiliary equation is nothing but 4m square minus 4m plus 1 is equal to 0. To find the roots of this equation, it clearly looks like we can write it as 2m the whole square minus 2 into 2m into 1 plus 1 square, right? So it looks like a square plus 2ab plus b square. So just write it as a plus b the whole square, that is 2m plus 1 the whole square is equal to 2. Equate each term to 0, we would get m is nothing but negative 1 by 2. These are the two roots. Agree? So the auxiliary equation is 4m square minus 4m plus 1. Now to find the roots of this equation, we can write it as 2m the whole square minus 2 into 2m into 1 plus 1 square is equal to 0. It looks like a square minus 2ab plus b square. Right, a square minus 2ab plus b square, so you write it as a minus b the whole square, right? A minus b the whole square. So it is 2m minus 1 the whole square is equal to 0. So equate each term to 0, we would get m as what? Positive 1 by 2 comma positive 1 by 2. The roots are real and equal. So our complementary function would be a plus bx into e power 1 by 2x. To find the particular integral, let us write 1 by the given question, that is 4d square minus 4d plus 1 into, what do we have on our RHS? We have 4. Now you can wonder that how can this be a non-homogeneous differential equation, right? Because on the RHS we don't have x term. Just because it is not 0, we say that it is non-homogeneous. Why? Because, see, I can write this 4 as 4 into 1, right? And we know that any term to the power 0 is nothing but 1. So this 1, I can write it as 1 is equal to e to the power 0 into x. 0 into x is nothing but 0 and e to the power 0 is 1. Agree? So we can write this as 1 divided by 4d square minus 4d plus 1, 4 into e to the power 0x. So after writing it in this format, what is the next step? We will have to replace d with a. And what is the value of a over here? The value of a is the coefficient of x. What is the coefficient of x in e power ax? It is 0. So the value of a over here is 0. So just replace wherever you have d as 0, we get 4 into 0 minus 4 into 0 again plus 1. Right? So we get 1 itself. Agree? 4 divided by 1. So here just write e power 0x. So we will be left with basically 4 itself. At the end, you can just neglect that e power 0x, just write it as 1. Agree? Or let me just write one more step. 4 divided by 1 into e power 0x, which is nothing but 1, which is nothing but 4 again. So what is our y? The value of y is nothing but, what was our complementary function? We had a plus bx. What was the roots that we got? It was 1 by 2, right? 1 by 2x plus 4. Yes. As simple as that. Okay. Let us solve another question that says, solve the 7th question, right? The 7th question says, solve y double dash plus 2y dash plus y is equal to cos hyperbolic x by 2. So we know the formula for sine hyperbolic ax. Agree? Now let me write down the formula for cos hyperbolic x by 2. Okay, ax, cos hyperbolic ax, which is nothing but e power ax plus e power negative ax divided by 2. Okay, now let me rewrite the given question. Right, it would be d square plus 2d plus 1 whole thing into y is nothing but e power, in the place of a, what do we have in our question? We have 1 by 2. So it would become x by 2 plus e power negative x by 2 divided by 2. Agree? Now the same thing, this is our given question. Let us find the auxiliary equation for this. What would be our auxiliary equation? Very simple. M square plus 2m plus 1 is equal to 0. This looks like m plus 1 the whole square, which is equal to 0. Equate each term, we would get negative 1 comma negative 1. So what is our CF? Our CF is a plus bx, since they are same, real and equal, e power negative x. Okay. Now let us find the particular integral. What is the first step? 1 by f of d, that is in our question we have d square minus 2d, d square plus 2d plus 1, right? Let me write it down. D square plus 2d plus 1 into, we have e power x by 2 plus e power minus x by 2 whole thing divided by 2. Yes, 1 by 2 is a constant. Let me take it out. I'll just write it over here. Multiply, right? 1 by d square plus 2d plus 1 e power x by 2 plus 1 by d square plus 2d plus 1 e power negative x by, I've just multiplied this with each term. Okay, so I've just multiplied, I've just given this to each term and I've just written this outside over here. Yes, now let us continue. All we have to do is replace. What do we have in place of d over here? We have 1 by 2. Here in place of d, the coefficient of x over here is negative 1 by 2. Right? Negative 1 by 2. So let us just replace it. So we get 1 by 2 can be written outside into e power x by 2 divided by 1 by 2 the whole square is nothing but 1 by 4 plus 2 into 1 by 2. So 2 gets cancelled plus 1 plus e power negative x by 2 divided by, again minus 1 by 2 the whole square is 1 by 4. Agree. Plus 2 into negative 1 by 2 plus 1. So clearly 2 and 2 gets cancelled. Agree. Even here 2 and 2 gets cancelled. What are we left with? We are left with 1 by 4 e power x by 2 divided by 1 by 4 plus 2 plus e power minus x by 2 divided by 1 by 4, negative 1 and positive 1. Don't forget the negative term. Okay, so plus 1 minus 1 gets cancelled. What is the LCM over here? What is the LCM of 1 by 4 plus 2? Clearly the LCM is 4. So cross multiply. 1 remains as it is. 4 2s are 8. We get 9 by 4. Agree. So let me just write it down. We have 1 by 2 into e power x by 2 divided by 9 by 4, or if I take it to the numerator, it becomes 4 by 9. Yes, it becomes 4 by 9 plus, if I take 1 by 4 to the numerator, it becomes 4 by 1 e power negative x by 2. This is our particular integral. Okay, now let us write down the final solution, that is y. Our y will be equal to, what were the roots that we got? D plus 1 the whole square, right? So the roots were a plus bx into e power negative x plus 1 by 2 into 4 by 9 e power x by 2 plus 4 e power negative x by 2. Okay, so our 8th question says solve d cube minus 8 whole thing into y is equal to 1 minus e power x the whole square. Yes, so what is the value over here? What is the value of a minus b the whole square? What happens to our RHS? We get d cube minus 8 whole thing into y is nothing but a square minus 2ab plus b square. E power x whole square is nothing but e power 2x. We can just multiply the powers. Agree. Now let us write the auxiliary equation as usual. The auxiliary equation over here would be m cube minus 8 is equal to 0. Agree. Now we can't send minus 8 to the other side and put the cube root, right? Let us use the formula a cube minus 2 cube, that is b cube. What is a cube minus b cube? A cube minus b cube is nothing but a minus b into a square plus ab plus b square. Agree. Now if we use that over here, m cube minus 2 cube would be m minus 2 into m square plus 2m plus 4. Agree. Now again to find the roots, m minus 2 is simple. To find the roots of m square plus 2m plus 4, m square plus 2m plus 4, if I equate this to 0, let us use the formula, right? Minus b plus or minus square root of b square minus 4ac divided by 2a. What is the value of b? It is 2 plus or minus square root of 4 minus 4 into a into c. We have 16, right? The value of a over here is 1, b is 2 and c is 4 clearly. Yes, divided by 2 into 1. So what happens? What happens over here is we have minus 2 plus or minus square root of negative 12 divided by 2. As usual, negative 12, it becomes what? It becomes square root of 12 into I divided by 2, because square root of negative 1 is what? It is the complex root plus or minus I. Next, what happens? We have negative, we can take 2 as common. We have 1 plus or minus square root of 12 can be written as 4 into 3. Again split it as square root of 4 into square root of 3. So you get 2 root 3. Right. And we've taken that 2 as common. So we are left with square root of 3 divided by 2. 2 gets cancelled. Agree. So we are left with minus 1 plus or minus square root of 3 into I. Okay, so what next we will be writing? We know that the values of m over here is -1 plus or minus square root of I. So our CF, the complementary function, would be e power ax into a cos bx plus b sin bx. Agree? So what happens? The value of a over here is -1 and the value of b over here is square root of 3. So this becomes e power -x into a cos root 3x plus b sin root 3 into x. Yes? Now moving on, let us find the particular integral. What would the particular integral of this problem be? The particular integral would be 1 divided by d cube minus 8 into 1 minus 2 e power x plus e power 2x. This is what we had, right? We had 1 minus e power x the whole square. Now let us just multiply. Let us give 1 by d cube minus 8 to each term. We would get 1 by d cube minus 8 into 1 minus 2 into 1 by d cube minus 8 into e power x plus 1 by d cube minus 8 into e power 2x. Alright. Now in the first term we have 1. Agree. 1 we can write it as e power 0 into x like in our previous problems. Yes. So that becomes clearly the value of a is 0 here. Here the value of a is 1 and the value of a over here is 2. Agree. Now what happens? We get 0 minus 8 e power 0 into x minus 2 divided by 1 cube is nothing but 1 itself, e power x. But over here we have e power 2x divided by 2 cube is 8, right? So we are having 8 minus 8 which is 0. Let me write down the first terms, then we'll deal with the last term. We have -1 by 8 e power 0x is 1 itself. Okay, then we have minus, right? Again we get a minus over here, so it becomes plus 2 by 7 e power x. Here the term becomes 0, right? 8 minus 8 is 0. The denominator term is 0. So what do? Differentiate the denominator, multiply x to the numerator. So f of d value is d cube minus 8. So f dash of d value is 3d square. 8 is a constant, so differentiation of a constant is 0. We already know that. I agree. So we have plus, multiply x in the numerator, replace the denominator with 3d square. Numerator remains the other term, e power 2x remains as it is. Again, the value of a over here is 2, right? Replace d with 2 in the last term. Yes? So we would get -1 by 8 plus 2 by 7 into e power x plus x divided by 12 e power 2x, because 2 2s are 4 and 4 3s are 12, right? Replace d as 2. Agree. So this is our particular integral. Let us write down the final solution, that is y, which is nothing but CF plus PI. What was the CF that we got? We got e power -x into a sin root 3x plus b cos root 3x, or vice versa, a cos root 3x, anything is fine, plus, okay, it's negative, right? -1 by 8 plus 2 by 7 plus e power, okay, into e power x plus x by 12 e power 2x. Okay. So we've solved 8 problems of case 1 of non-homogeneous differential equation. Let us learn about more types of differential equations in our upcoming sessions. Thank you.